was wondering why the audio wasn't working, I've muted the damn thing. This is just a test to see if the audio is working. Okay, I've got audio. Alright, I think everything's working. Anyway, okay, so I thought I would stream this. I don't know if it's going to be used to anybody who is on our Discord channel and wanting to learn the Godot gaming engine. I'm new to the Godot engine myself, but I'm not new to programming. So what I thought I'd do is redo the 2D tutorial using GDScript right from beginning to end, so that anybody's interested in playing along. I mean, I'm going to get something out of it as well. I'm doing it again, but it will refresh things in my mind as I'm going along through it. And if nobody watches this, it doesn't matter. I'm not losing anything anyway, because I think going through this tutorial again is going to be used to me. What I'd like to take this eventually is to introduce the C++ aspect. C++ is an area I'm very familiar with. I've been using it for a number of years. GDS, the scripting language, I'm new to. So that's why I want to do this tutorial again. Anyway, with that in mind, I'm going to make a start. Okay, so I'm just going to put the music on in the background, and I've uninstalled the engine, so I'm going to restart everything from scratch again. And I think the easiest way to do it is using Steam, because there's an installation for it in Steam. So all I'm going to do is install it from there. There are other ways to install it. If you obviously go into the main website, there's different ways you can do it, but I thought the easiest way is everybody who's probably wanting to develop games are typically going to be gamers themselves. So you just start from Steam itself. Which one did you do? We'll do that. Alright, so while that's downloading again, oh yeah, so something else I wanted to comment on, and I did previously look at this and how that working, is rebuilding it from source on Windows so that you can have the debug symbols for when you're developing with C++ and debugging with C++. It seems quite easy to do in terms of building it, but there's a Visual Studio solution if you're into using Visual Studio, which we'll come on to. It's a bit more onerous, and there are certain tools that you can use to help with that, but that's obviously for a later chapter. Okay, so in the meantime, this is what we're going to be looking at. Let's have a look at the 2D tutorial. We're going to work his way through this. Whether we'll get through it all in one tonight, I don't know, when it's a video, whether I'll even continue doing this video, I don't know. But let's see what happens. Let's see how long it takes to waffle way through it. What we're going to be going through this. Now, I've been through this already once already. If you haven't, it's probably worth you reading some of these links. Can I paste them somehow in that? It would be useful. I wonder if I can paste them onto this Twitch stream thingy. Can I put them into the channel somewhere? Just have a quick look while that's downloading. Because I mean, it's pretty easy enough to find. If you just type introduction to Godot or Godot tutorial, you'll come to this link. In fact, rather get bogged down with that, in fact, what I'll do is I'll make a note of it somewhere that I can come back to. So there's the introduction to Godot. Tells you what it's about, what it's good for, what you can do, what different programming languages you can do. The simplest one, so if you're new to programming, is going to be GDScript. I'm not new to programming, and I'd rather do it in C++, but GDScript is probably the fastest in terms of prototyping. Or you can also, as it's in there, use C#. I'm not new to C# either, that's what I do for a living. But GDScript, I think, and if you read that, you'll see this. GDScript is probably optimal if you've not had any other programming experience in terms of entry learning curve, and also because C# is nice if you already know C#, but there are certain trade-offs apparently that means C# can potentially be even slower than CD script, and that's to do with marshalling data types across from one system to the other, one byte type of byte code to the other. Anyway, I'm jumping ahead of myself. So the main purpose of being here is to go through this tutorial. I'm going to go back into here again, make sure I get the right link. Obviously there's different versions of Godot script. We're going to make sure we got the right one installed. Hopefully my Steam install now has caught up. And there we go, there's Godot game engine. So let's follow along with this step. So obviously these links, I'm gonna paste these into, or the first one I'm gonna paste into the thing later, into something relative to this post later. Maybe I should put them into our Discord server. Oh yes, if for whatever reason you've not seen the Discord server and you're seeing this, there is a Discord server that I have links that you can run to, where we talk about Godot and general programming. If you're interested in anything like that, just come around to the Discord server. So let's have a start. Let's just crack into this. So I'll post a link later. So here we'll learn to create a complete 2D game, structure a simple game project, move the player character around to change its sprite, spawn random enemies, and count the score and more. Well, I start with the 2D. Simplicity, obviously. Prerequisites. Oh, we didn't do that bit. This step is the step-by-step tutorial is intended for beginners who follow the complete getting started, and show anybody that bit. Perhaps we should have gone there first. We should do actually. This is another prerequisite that people should be aware of. And we'll skim over this. Maybe we make this a two-part video. I'll put the link up there because really it's kind of one of the prerequisites. And some people on this Discord are already interested in Godot as a game engine. Some people don't really know what it's about. So let's start. So we're beginning from a standstill. Following lessons here to prepare you for your test 2D game. Nodes and scenes. So, okay, so let's have a read through this. The nodes, fundamental gaming blocks, like ingredients are in the recipe. Lots of different types. Each has got a name, it's got properties. You can receive callbacks, in other words, stuff can call methods on it. Every frame that's updated, so every time something happens in a game engine, boom, it'll call it back. We can extend them, put new properties and new functions in them, and then we string them together, add them together as you add them to another node as a child. So this last characteristic is important to get the nodes from a tree, which is a powerful feature to organize projects. Basically, you build things together using these nodes. Different nodes have different functions combined and produce a more complex behavior. So you can build a player character that the camera follows using a character body 2D node, a sprite 2D node, a camera 2D node, and a collision shape 2D node. So we'll see these in the engines as we get through the tutorial shortly. So scenes. Again, all I'm doing here is really going through this tutorial, but it's kind of, you can do this by just going through and reading through this tutorial itself, but I think this might be quite useful if somebody's watching along to get a feel for what it's about with actually going through it, or just getting a feel if they're interested in this kind of thing. So I'm not actually introducing any new content here, I'm just going through this content, but hopefully it will be useful somewhere down the line. Anybody's interested in learning Godot on our Discord server. So scenes. So we organise nodes in the tree like a character, and you construct a scene. And then scenes work as new nodes in the editor, and you can add them as a child of an existing node. In that case, the scene appears as a single node with its internal hidden. This is called encapsulation. Right. Scenes allow you to construct structure game's code however you want. Compose nodes to create complex they create custom and complex node types like game character, runs and jumps, life bar, etc. etc. There we've got a player with a mannequin, ability shape, and a state machine with a state machine, which will dictate what all the actions that you can do and where and when. There's a camera rig. So the Godot editor is essentially a scene editor. It's got plenty of tools for editing 2D and 3D scenes as well as user interfaces. And the project can contain as many of these scenes as needed. Engine only requires one as your application's main scene, and this is the scene that will first load when the player runs the game. Okay, so this then talks you running through creating your first node. This jumps into 3D. We're not going to go through this. Obviously, that's going to be there for looking at, but I'm not going to go labour too much about this because we're about to do a tutorial on it. But one thing that we can see is each node. This bit's sort of important, but we'll see this as we go along. You can change node properties. If you would change the behavior, it's attributes or behaviors which can act on those properties, which consume those properties. Okay, and then we can run the scene using that little button there. And we save the scenes. All the scenes are stored in text files, which is nice. It makes them all nice and friendly to source control. There's another video on the Discord server if you've never seen source control. Talk about how to use source control. Git. Alright, so yeah, very simple hello world application. Setting the scene, set the main scene. Okay, I'm just going to skim through this bit here, right? Creating instances. So, we saw that a scene is a collection of nodes organized in a tree structure with a single node at the root. And we can split them into any number of scenes, and that helps us break down and organize into different game components. And then we create as many scenes as we like and save them with this .tscn extension, stands for text scene. Label section from the previous lesson was an example. We call those files pack scenes as they pack information about your scene content. Yeah, this is actually quite an interesting one as well. I remember doing this one. This is, if you're interested above and beyond the little tutorial, whatever the 2D tutorial we're about to do, this is kind of worth going through as well. This little tutorial, this little example here, especially here, it just creates a few sprites and has them bouncing around with very little input. So this is well worth it. I wonder, maybe we should do this actually. No, we won't do this. We won't do this because we're going to jump straight onto the. We're going to jump straight into the 2D game, I think. But instancing is something that probably should be noted, and I'll put it in my notepad. Links for later. Maybe I should post these straight into the Discord server. I'll come to that later. Right. As mentioned in the previous part, instance scenes behave like a node. Editor hides their content by default, and then we create instances of them all. So once we've got a scene, we can create as many of them as we want, and we change the behavior of those individual instances by giving them different properties. That might be the XY coordinates, or it might be the gravity, or fields that affect gravity. Whatever we choose to do with that. So this is quite an interesting example, but I'm not going to do this one now. If you're interested, it's worth following. Okay, and basically all this does is it ends up dropping some balls on here, and then when you press play, the gravity of these moves them all, and then I think the tutorial adds more gravity to some of them, so that those balls effectively act like they're heavier. All of that is done very, very simply. In fact, I don't think there's even any script associated with this. There's no script. It's just basically done by dragging things, adding new scenes, nodes, and changing the properties, the already existing properties, without adding any new ones. All right. Scenes, instances as a design language. Instances and scenes in Godot offer an excellent design language, setting the engine apart from others. So we'll see about that. We designed Godot around its concept from the ground up. we recommend dismissing architectural code patterns when making games with Godot, such as model view, modern controller. And so, interestingly enough, I've been doing that today in C#. Instead, start imagining the elements players will see in your game and structure the code around them. Okay, so now it talks about breaking that down and showing individual scenes and nodes, instances of those, and breaking that down into individual components. Okay, program centers spend a lot of time designing abstract architectures, trying to fit components into it. Yep, that's true. Anyway, that is well worth reading as well. Let's just go back. I don't want to go into too much into detail there. We're going to jump into the game engine 2D tutorial shortly. So instancing is the process of producing an object from the blueprint. If you've come from an object-oriented language, it's the process of turning a class into an object, usually with a new keyword if it's C or C#, or C++. Anyway, with scenes, it gives you your ability to divide your game into reusable components, tool to structure and encapsulate complex systems. In other words, just keeping the bits relevant to the public for public consumption that need to be, with so not overcomplicating it. Keep the complexity internal. All right, scripting languages. So, scripting language. We're going to use GDScript in this tutorial. It's not necessarily going to be my favorite because I'm more familiar with other languages, but from what I've seen of it so far, it's pretty nice. It's very easy to use. It's very Python-like. So if you've done any bit of Python, and even if you haven't done Python, it will feel fairly intuitive to begin with. And I think they've gone for simplicity. And they've also managed to obviously have a pretty decent performing game engine as well with it. So despite it being interpreted script. So anyway, GDScript is what we're going to do within this tutorial. You can do it in C#, and relatively seamlessly. In fact, I think the tutorial even has an option that shows you how to do that. But we're going to stick with GDScript. So scripts attach to nodes and extend behavior. So that means scripts inherit all of the functions and the properties of the node they attach to. But what do you mean by inherit? Well, basically what it means is that if you have a node of a particular type, you can call everything, you have access to all of the public properties and behaviors that object, that type already exposes. Oh, there you go, there's me waffling on and it tells it here. For example, take the game where a 2D camera follows a ship. The camera 2D node follows its parent by default. Imagine you want the camera to shake, and this feature is not built into Godot. You could attach a script to the camera node and have the code shake and code the shake. Okay, here we go. So our 4 gameplay scripting languages. 4. Oh yeah, GDScript, C#, C and C++. Okay, yeah, there are also Rust. I thought I did think about looking at Rust before, but there's no need for that right now. So GD extension is an interesting one. Definitely want to come on to GD extension. It's the way of getting the best out of the game engine. If you want to get the maximum performance, but for that you want to be using C, C++, potentially Rust, but that's only provided by a third party. But anyway, I'm waffling again. Let's carry on with it. We're going to be using GDScript at the moment. You can use multiple languages in a single project. It's interesting. Yeah, well, I think that is going to be interesting to look at when we come to past the prototyping stage. Which bits want to be optimized and which bits don't. If we want to optimize it, we use C++ or we use C. I don't really see the benefit of using GDScript and C# other than for familiarity for those who already know C# but don't need GDScript. Which language should I choose? If you're a beginner, I really recommend to begin with GDScript. Certainly easier than C++, I can guarantee you. Pretty much every language is. Okay. We made this language specifically Godot and the names of game developers, lightweight, straightforward syntax. provides the tightest integration. There's an example script. Okay. I mean, that to me already looks like English. This is very Python-esque, isn't it? You can see, I mean, and it's object oriented as well. You can see what it's extending or inheriting. You can see its member functions, such as process there, and its parameters. That's the bit I don't like about it. That's the bit I don't like about Python, is it's not got types by default. It's just dynamically typed language. But we will come on to addressing the workarounds for that, because the other nice thing about this language is you can add strong typing. You know what that means? We'll come on to it. Okay. So there's a bit about GD script. Object orientated and imperative. What does imperative mean? I don't mean being imperative. Imperative programming uses statements that change the program state. Okay. All right. I don't get too much off topic. Right, simple syntax that leads to short files, blazingly fast compilation load times, tight integration, built-in vector and transform types, supports multiple threads, no garbage collection, that's nice, gradual typing. What do you mean gradual typing? Variables have dynamic types by default. Oh, okay. We can also provide type hints for strong type checks. That's the bit I said we're going to come on to. GD scripts looks like Python, but it doesn't work the same way. Inspired by multiple languages, including Squirrel, which is a language I've only recently heard about. It's just nuts, isn't it? Anyway, okay, so you can also use C#.NET. I'm not going to go too much into that at the moment, because I'm not going to be worrying about it, but it can be doable. You can also use C++ by GD extension. I know a bit about that in terms of how to integrate it. I've been looking at it a little bit, but I need to expand on that further. I'm not going to go too much into it right now. Alright, so let's have a look at creating the first script. This is probably good as a first step, actually. In fact, you know what I'm going to do? I'm not going to do the full 2D tutorial in one video, because it's going to be too long. I don't know who's going to be watching this video anyway. This is going to be a rough look at Godot and GD script. And then for the next video, I can look at the 2D game tutorial. Let's just walk through. Let's just talk our way through this first, and then I'll probably can this video and I'll do another one if anybody's interested in watching. I might just do it as a video anyway. Right, okay, so create your first script, because that's the thing. This is the thing we're going to be doing most of our time, especially when we're looking at GD script, our prototyping of our game that we've got planned. We're going to be creating scripts, basically creating and modifying scripts. There's going to be a little bit that we're doing with dropping things into the editor and stuff like that, but most of our work is going to be writing script. So this lesson, the first thing we're going to do, and again, this script here is probably this, because I could do this tutorial now. I don't know how much merit there is doing that. The video is already 30 minutes long, so I'm conscious if it makes this too long, nobody's going to watch it. So what I'm going to do is just talk us way through this script here, and then I'll do another video later. So all we're doing in this video is having an icon turn in circles using GD script. It assumes you've got programming foundations. That's a big assumption. Well, I do. Hopefully you do too. If not, that's what our Discord servers are for, and you can talk through these kind of things. Right. This is a useful thing as well. This is actual scripting reference. I was reading through that in detail the other day. How much of it stuck, I don't know, which is one reason why I want to refresh myself. These tutorial things stick and you use them all. Where was it? I've lost my. Okay, all right. So we create a new project. Is it worth doing it now? Or should if I do this all the way through, it's going to get long. Or is it? Maybe I should just leave this video at a position like this and then See if anybody wants to do an online session together from the Discord server. I don't know. I'm conscious of this getting too long. Yeah, I think that's what I'm going to do. Or maybe I should just rock and roll and create the script as an example. Or should I just jump into the 2D? You know what? I'm gonna leave that. I'm gonna leave that up for debate. Should I create a script in here and talk about the script? No. See what? Now what? Nothing. Let's just carry on. Let's crack on. But we're just going to talk through the script. It's well worth doing this if you've not run the script before in 2D script. I've done it. I've done the 2D tutorial, so I don't really want to go through this again. But kind of sometimes useful to watch somebody else coding along. But I'm just going to talk through this, and we can do more when we actually come to start looking at 2D again. Right. So that's what we're trying to achieve. Like I'm moving around in a circle. Or sprite, should I say, moving around in a circle. So what we do is we create a new project. And it's fairly straightforward. We will start that from Steam and follow the options that are on that link there. It's very, very easy to do. And then we create a 2D sprite. A sprite 2D is called. And as we said earlier, we were discussing earlier, we've got different nodes. We've got a node 2D. And underneath that there's a sprite 2D. So we create a sprite 2D. These are effectively the things it inherits. So sprite 2D inherits or extends in I start using Godot terminology. Sprite 2D inherits from node 2D, which inherits from node. So once you've created that, your scene should just have a sprite 2D node. Right, now what the tutorial is doing is giving it an image to display. So there's a texture property, and if we change the texture property by that drop down there to be the icon that gets associated with the default project you just created, which is this little thing. Obviously you could replace that way if you wanted. Then now that texture becomes associated. That's the property of this sprite 2D. And then you click and drag the icon into the viewport being the visible part of the game. We're in the 2D world at the moment, so it's just like a 2D viewport. So now we can create a script that is associated with that sprite. So you right click on it, click doc, attach script, and it's asked us to give it a name, I think. Oh, when we save it, we can try and save it. Okay, let's leave all these things default. Don't worry about C#. Okay, now this, when you start the script, it will take you into an editor, and the thing at the top of it will be just like this, or here. Where is it? Oh, it's gone. Extends. First thing it'll say is extends, and this effectively says what is it, or what does it inherit its behavior from. So every GD script file is effectively a class. Implicitly, each GD script represents the type of object, a classification of an object, and the extend defines what that inherits from or it extends from. In this case, it's sprite 2D. Yes, we know that. Can we just create sprite 2D? So our script will get access to all the properties and functions of sprite 2D, including classes it extends, such as node 2D canvas item. It's in the canvas item. Canvas item. Oh, it's there. I don't know why that's dimmed out. I didn't notice that before. So we've got node sprite 2D extends or inherits from node 2D, which extends or inherits from canvas item, which extends or inherits from the base node. So there we go. So we get access to all that. And don't omit that line, otherwise you're going to have problems. Alright, so function, our script doesn't do anything, but we're going to make it print stuff at the bottom output panel. So here's how you define a function. Just give it func and then a name. By convention you put an underscore if I should have done into that yet. Well, you can't put an underscore there. It keeps it private to this script. So let's just follow what it's doing for now. It will probably explain it as well rather than me waffling back to earlier. Okay, so effectively very similar to Python here. It's almost identical, isn't it, to Python. We've got function. The indentation indicates blocks and code flow. So print is print is a part of this function. When this init function is called, it's going to call print hello world, which I believe appears on the bottom in the debug area. So it's going to show you. So function close it. Why don't I just read that here? So define a new function called init. Name for our class is constructor. Oh, that was it. Init is this constructor. This is why I needed to do this stuff again, because I forgot is that's equivalent constructor. It's the code that will get called when this object gets created. Called a constructor in C++ terms. But anyway, engine calls init on every object and only creates it in memory. Indent-based language, as I was just discussing. Now, when we save it, we'll ask for a name. Now, and if we run it, first thing it's going to do, it'll create our object, call it its constructor or init function, and that'll print our hello world at the bottom there like that. Now it suggests deleting that. Now it wants to make it move around and rotate. So we're going to give it two member variables. So member variable is state that gets associated with a particular instance of that object as it gets instanced. I'm trying to use Godot terms. Okay, so we're adding the pixel movement speed in pixels per second, and then the angular speed in radians per second. So after extending it, we are adding these variables. So speed is in 400 pixels per second, and the angular speed is 3.14 blah 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 radians per second. Member variable is sitting near the top after the extends, and so every node that's attached to this script will have its own copy. So every time you instance it, each one gets its own speed and its own angular speed. And that's important to remember as well. I mean, it's fairly obvious that would have been the case, but angles work in radians by default. Right, okay, so to move our icon, we need to update its position and rotation every frame of the game loop. So our game, the Godot game engine, is going to be going around all its physics and its animation and whatever else it's doing, taking the input and blah, blah, blah. And every frame, it will call this function called underscore process. So if we implement underscore process on this particular object or particular class, we can do updates in there every frame, every time the game loop iterates, it will call our process function. We do whatever we want in that. It also gives us a delta, which most game engines work with, and basically that will be the time that elapsed, the times elapsed since the last time it called it, and that allows the physics and animation to take account for the fact that not all systems run the same. If you've got a stupidly fast machine, that delta will be smaller. If you've got a really slow machine, that delta will be higher. But if you don't take that delta into account in your physics and your animations, then you would have an advantage, or things would look very different and a lot faster on a super fast machine compared to a slow machine. So most of them provide that delta. Okay, this explains it fairly well anyway. It's slightly different. Games work by rendering many images per second, each called a frame. We measure the rate at which game produces images in frames per second. I think everybody will know that because it's games. Most games aim for 60, 30, okay, I'm slower. 90 to 240 for virtual reality games, and that is the reason why I want to look at GD extension, so that we can get the best frame rates possible when we come to the mixed reality version of the game I would like to write. Godot script for the win for now though. Engine and game developers do the best to update the world game world and render images at constant time intervals, but there are small variations in the rendering time. That's what I was trying to say earlier. Yeah, you might have a fast machine where if you didn't take into account the delta, the well, it worded it better. That's why Engine provides us this delta time value, making motion independent of the frame rate. So now, not what we're doing now. Okay, so there we go. So we had. Yeah, that confused me because I'm like, where's it getting his rotation variable from? That rotation is a member variable on one of the, probably the node 2D, probably one of the class that extends probably from, it's not really relevant, that relevant, probably from node 2D, node 2D, that probably has the rotation member variable. Because I was thinking, where's rotation gets it? Right, okay. The rotation, by setting rotation, I think that will be telling it how that is telling the game engine how far we want to rotate, because that is a known variable that's already used. So all we're doing is every frame we're going to take whatever angular speed we have set here, which is pi 3.14544, and then we're going to multiply that by our speed, which was in, what was it, pixels per second, and add that. So plus equals, if you haven't seen that before, that means rotation equals rotation plus. If you haven't seen plus equals, that adds the that increments the rotation. So, and we're doing it with an underscore process. So this is going to get called every tick of the game engine. Alright. So function finds the new function. Oh, done that. Don't know that bit. Let's go over that again. Oh, here we go. It talks about the leading underscore. Notice how underscore process and underscore init start with a leading underscore. By convention, Godot's virtual functions, that is to say, built-in functions you can override to communicate with the engine, start with an underscore. Just to add to that, in case you don't know what virtual functions are, I mean, it's sort of describing it there, but just going into a bit more detail. A base class, one of the like the 2D node or whatever the things this extends, may have a default behavior for underscore process and underscoring it. Well, not underscoring it, actually, constructs are different, but it may have default behavior for underscore process. And if you want to change that behavior, you can override it. So overridable functions where you can change that behavior from whatever their base implementation was are known as virtual functions. Okay. You've also got abstract one. Oh, actually, I'm not going to go into that for C++. So I don't know if that's a Godot thing. Anyway, overriding this process function allows you to change the behavior. It's not like you're inventing a new function there, you're reusing an existing function and overriding it. You can create your own functions, and you will be creating your own functions that do whatever you want to do on top of that, and you'll be calling them. But to override existing behavior, you will be changing base class versions of functions. Sorry, overriding abstract functions. Oh, let me rephrase that. You'll be overriding virtual functions. Let's use the right terminology. Okay, so the line inside function, blah, 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 increments our sprites every frame. We just went through that, didn't we? So it increments our sprite's rotation at every frame. Here, rotation is a property inherited from the class node 2D. Oh, there you go. That's that's right. I got that right. Which sprite 2D extends, controls the rotation. Now, if you notice, it's using that delta there, which came from the which, as I said, that was the delta between the last time that this was called. So this is the tick of the game engine. How long since the last tick of the game engine? So by timing it by the delta, you ensure that you are getting consistency between any a slower a slower machine and a faster machine. Okay, so now if we run that scene, we're saying every tick increase the rotation by our angular speed and our delta, and that gives us this. Right. So that's what's going into next. We're coming up to 45 minutes. I'll probably leave it when I finish this particular video, this particular tutorial thing. Right, so let's make them move. So now what we're doing, is adding to the process. It's a bit incomplete, that one, because it's not showing it as part of the underscore process, but that's all part of the process function. And what it's doing is creating a new variable called velocity, and it's going using a vector2 type up, rotating it by based on rotation times the speed, and then its position is increased by the velocity times the delta. Okay, there we go. That defines a new variable. If we put it at the top, it defines a property of the class, a member variable, or member variable. Inside a function, as we've done now, it defines a local variable, only exists within the function. So now we define the local variable velocity, 2D vector, which is both represents the speed and direction. And then to move the node forward, we start with a constant, the vector's class constant vector up. Okay, so that's a vector pointing up, and rotate it by the vector method rotated. And then we add our rotation into there, which is a vector. Yeah, that's our rotation from that we inherited from the node 2D. It's a vector pointing forward, rotated to icon, multiplied by speed. It gives us a velocity we can use to move forward. So we add velocity and delta to another position to move it, and position itself type vector 2, built-in Godot representing built-in typing Godot representing 2D vector. Okay, and then we run the scene. Now this thing's in circles. Okay. Right. Obviously, this doesn't take into account collision detection or anything like that. And there's the full script incompleteness. Okay, so we've got our member variables. We've got which is the speed and the angular speed. So that's the rotation in radians, and then the speed. And then every tick of the game engine, we will build the rotation and the velocity and update the position. And that's that. Alright, yeah, it's going to be too long if I get into the whole thing now. So into the 2D game engine now. So I'm probably going to cut it there. And yeah, I'll start the 2D game engine, give 2D game tutorial in the next video or something. If I decide to stream it. Alright, well, if you've been watching, thank you very much. See you in a bit.